Well, hello, everybody. I want to talk about what exponents are in this video, and that's important because no matter what you're doing with math or numbers, uh, probably you need to know what an exponent is at the bare minimum. Maybe you can't do the most difficult calculation that involves exponents, but you at least know what it is, and you've got the basic understanding, and that's my goal in this video. Okay, so first, I'd like to distinguish two different things. There are exponents, and then there are these other things called coefficients. And they're different, but we should know about both of them. And if I'm going to talk about one, I should probably talk about the other. Okay? Exponents refer to repeated multiplication, and coefficients refer to repeated addition. Now, I'll give you examples of both. Okay? So first, with the exponent, suppose I have 2 to the 5th power, which is the way I would read that. That 5 is called the exponent. The 2, the thing that gets the exponent, the thing that we raise to the power, that's called the base. All right? But exponents do mean repeated multiplication. That's what they indicate. So 2 to the 5th power means you multiply 2 by itself 5 times. And so here I have that. 2 times 2 times 2 times 2 times 2. I got 5 of them. And then if you just do the math there, I'll get 4. And then if I multiply by 2 again, I'll get 8. Then I'll get times 2 again, 16. Then times 2 again, I'll get 32. All right? So in its most simple form, that's what an exponent is. Now, when we do math, if we see parentheses, we need to pay attention to those parentheses. So here I have something kind of like that. But in addition to having some numbers, I have a variable, y. Y could be a number that takes on a lot of different values. It could be some number that's not known at the moment, all right? But this is math, and y is a number, okay? It's just not revealed at the present time. Algebra deals with situations where you're doing math, but you don't know what the numbers are necessarily, and so we label them with letters, okay? Anyway. So I was talking about parentheses. So notice how the parentheses kind of group the 2 times the y together, okay? And then I get the exponent. So you might say, well, what's happening there is that the base is the 2 times the y, right? It's this whole thing right here. So that whole thing has got to get multiplied by itself 5 times, which I have right here, okay? And then we could do the math on that is further from this point. How did I get 32 times y to the 5th power? Well, there's a lot to know in math. And I wanted to make this video on exponents, but whenever I do one thing, I run into other things that you have to know about also. There's this thing in math called the associative property, which applies to numbers. It says the order that you multiply numbers doesn't make any difference. So suppose I have 2 times 3 times 4. Then if I was to do this calculation, it wouldn't matter if I multiplied 2 times 3 first and got 6, and then multiplied that by 4 and got 24, versus if I multiplied 3 times 4 first and got 12 and then multiplied 2 times. See how I get the same thing? So the order you multiply numbers doesn't matter. In addition to that, you can rearrange them. So I could even say, well, 2 times 3 times 4, it doesn't even have to be in that arrangement. It could be 4 times 2 times 3. You can mix it up any way you want, okay? That's called the commutative property. Now, things like that probably aren't that hard to believe, but I want to say that's what's going on here. If I rearrange this and multiply it in whatever order I want, I got 5 2's, so that's 32, so that's how I got the 32. But then I got y multiplied by itself 5 times. What would you say that is? I can't calculate that, but I can say that's y to the 5th power, all right? So you see how I did that. Now, if I could calculate further, I would, but without knowing the y, I can't tell you anything beyond what I have right here, okay? Now, can we tell the difference between 2y grouped together by the parentheses to the 5th power and without it? What would be the difference there? In that case, that exponent, does not apply to the 2. It has nothing to do with the 2. It just applies to the y. So if you had to write that out, you would have to say something like, well, you've got 2, and then it's times y to the 5th power. Well, then that means that y gets multiplied by itself 5 times. See, I wrote it out. That's what y to the 5th power means. I'm just writing it out so that you know that. Now, is it useful to have it written out this way? It might be good to know, and I'd like you to know that that's one possible way to think about this, but why did I write it back like this? Well, because maybe it's okay to just leave it, all right? But whether I leave it like this or not, you understand what that y to the 5th power means. I've got y's multiplied together like that, like in the way that I told you up here, okay? All right, so that's what exponents are. Now, I told you I would compare that with what a coefficient is. So, okay, coefficients. Coefficients refer to repeated addition. So that's like this. If I say 4y, here the 4 is not an exponent. That's called a coefficient. Coefficients refer to repeated addition. That means I get y added to itself 4 times. Do you see why I might have wanted to bring that up in this video? It's like coefficients are kind of like exponents. It's just whether you're talking about repeated multiplication or repeated addition. Okay, so 4y, you add y to itself 4 times. 5m, m is another variable. It's just an unknown number. You add m to itself 5 times. That's what it means. Okay, is it useful to write it out like this? If I say 4y equals y plus y plus y plus y, it might be. I mean, who knows what you might do with math someday. But for me to tell you now, I'm pointing it out so that you're aware that that's what it means, okay? It's better to know than not. Now, I mentioned before that we need to watch out for parentheses. So I thought of an example that sometimes confuses people, or it's something that they at least get wrong instinctually, okay? Do you see these two problems? I got negative 2 to the 3rd power, and I got negative 2 to the 3rd power again. If I was going to read these out loud, I might state them the same way. I might say that they both say negative 2 to the 3rd power, but they're different. And what do you think the difference is? Well, here, notice how like the lack of parentheses might seem to suggest that the exponent is not really attached to the negative, like it doesn't apply to it. Whereas this one, where I have the parentheses holding it all together and then writing the exponent attached to the parentheses, there it might seem like that negative gets the exponent applied to it. Now, the way that we would, as a result, understand these differently is that this is like a -1, because if you were to say that there was a number there representing that negative sign or that dash, it would be a -1, but it's like a -1 times 2 times 2 times 2, right? I get a negative, a dash, a negative, then times 2 multiplied by itself 3 times. So I get what? I get negative, and then what's 2 times 2 times 2? I get -8. So that's how we would understand the relationship between the negative and the exponent if it was written this way. What about like this? Well, I mean, in this case, remember, every time we deal with an exponent, we have a base. The base is the thing that gets multiplied by itself repeatedly according to whatever the exponent is. And so here, that entire number, -2, is the base. It's the thing that gets multiplied by itself 3 times. So that would be -2 times -2 times -2. This says that you multiply -2 by itself 3 times, whereas this one doesn't say that. It says something a little bit different. Now, if I work this out, I'll get 4 times -2, which is -8, all right? Okay, all right, now here you might say, all right, well, those were different, but you got the same thing. Does it matter? Well, let's see, I'll leave you to do this one. What's -2 to the 4th versus what's the number -2 raised to the 4th power? How are those different? Okay, would you get the same answer in that case? So maybe you could try to do those, pause the video, see, or think about whatever you think the answer is. This one is -16, and this one's +16, by exactly the same thinking as these. Okay. So let's go on to the next thing. There are lots of rules that apply to exponents. okay? And I will tell you the most important ones right now. The first one is, now this mainly applies to algebra. Now, whereas algebra is math when you are dealing with letters, letters being representing unknown numbers, okay? It's still math, but you just don't know what all the numbers are. When you multiply like things, you add their exponents. So here, I've got some variable y. And if I multiply y to the 4th times y to the 7th, the y's are like things, okay? And yes, when you multiply like things, you add the exponents together, and I get that that's the same thing as y to the 11th power because that's just what 4 plus 7 is, okay? Now, you can take my word for that one if you want to, that's just a rule, and if you were to see something similar, you would apply the rule as such. But in math, you do have the power to figure things out. I mean, you don't have to take everything on faith, and if you ever did get a little bit confused, you could try to figure things out. I think that that's worth knowing how to, something everybody should know how to do. So why do you do it like this? Well, because what's y to the 4th? Well, there's 4 y's, okay? And then I'm going to multiply that times y to the 7th. Okay, what's that mean? Y to the 7th, that's 7, so I multiply y by itself 7 times. Okay, so 4 here, I got 7 there. Well, what's that look like? Does that look like what an exponent is? What's an exponent? An exponent indicates repeated multiplication. So what are you looking at right there? I'm looking at multiplying y times itself a bunch of times. How many times? Well, 4 here and 7 there. How many altogether? 11, all right? So that's why you add the exponents when you multiply like things together. Now, I won't go prove the answer to every problem. I'm mainly mentioning this to say that, well, you know, it's possible to figure things out for yourself. If you forget the rule, if you get a little confused, you can do that. Now, this rule applies anytime you multiply like things, okay? So whether those things are a y and another y, or 2r, like again, 2r, that's a variable. I know what the number 2 is, but r is an unknown, okay? But nonetheless, this is 2r to some power times the same thing, 2r times some other power. So what I'm saying here is this rule is still applicable. Anytime you multiply like things, you add the exponents together, okay? All right, so we can do that by the same rationale that we could in this one. What about over here? I mean, I guess my rule says if you multiply like things, you add the exponents. You know, y and y are like things. 2r and 2r are also like things. What about y to the 4th times x to the 4th? Well, those are not like things. Like y and x are two different things. Obviously, they're not the same, okay? In the context of algebra, then they'll probably be different numbers. Okay, or we would have to at least assume that they might be different numbers. So here I said, what's y to the 4th times x to the 4th? It's y to the 4th times x to the 4th. I can't really say anything else about it. Okay, I guess I could say it's also x to the 4th times y to the 4th. You know, if I wanted to, but it's like I can't do anything with the exponents, is my point. What's my rationale for saying that it's equal to x to the 4th times y to the 4th? Well, because remember the arrangement that you have for numbers doesn't matter, like 2 times 3 times 4. You can rearrange that however you want. It's also 4 times 2 times 3. Anyway, okay, so I could at most say that. I can't do anything with the exponents because I'm not multiplying like things. What about this though? Okay, I wanna briefly mention something different. Since this is, I intend this to be a review video, I want to touch on some things that might trigger your thinking and your memory. Here I'm talking about what if you multiply like things. What about if you add like things? Like is y and y, I did say those were like up here, right? Okay, yeah, okay, y to the 4th times y to the 7th, those multiplying like things, you can add the exponents. What about when you add like things? Well, that's different. I mean, the rule doesn't say anything about adding or subtracting. It says if you multiply like things, you can add the exponent. So I want to tell you that that rule is not applicable to this, even though this looks very much like that first thing I showed you. Here we're trying to add similar things. I wouldn't say they're like, because y to the 4th is, I mean, in terms of adding together, not really the same thing as y to the 7th, okay? So I can't really re-express that in a useful way. I'm just stuck with it the way that it is, okay? Now, the way that in algebra people sometimes talk about this is that this is like adding an apple and an orange. It's like adding apples and oranges. Apples and oranges are different. What could you say you had if you had one apple and one orange? You could say you had an apple and an orange. I can't condense that into some smaller statement, okay? You might say I have two pieces of fruit, but then I've changed it and I'm not talking about apples and oranges anymore, okay? So I can't do anything with this, but I can with this, okay? Y to the 4th plus y to the 4th. These are called like terms. I can add those together because here I'm talking about adding exactly identical things together. It's like saying, you know, what's one apple plus one apple? It's two apples. Y to the 4th power is exactly the same thing as y to the 4th power, okay? And so I could say that I had two of them. That's what that means. All right. Now, this is a review video. I'm trying to touch on lots of different things, but how does this relate to where I started? Well, that's a coefficient, 2 times y to the 4th. What does a coefficient mean? Coefficients refer to repeated addition, right? Okay, so that's why I can add like terms. Y to the 4th plus y to the 4th. There are two of them. It's 2y to the 4th. Okay, now that might seem like I'm going off on some other direction, but I can't mention this and show you how to do that without also mentioning this and this, okay? Because so many people would see this one, seem to grasp it, okay, be fine with it, but then if they saw that out of nowhere in some other context, they might think it's the same thing and they might start adding the powers together, okay? But we can't do that, all right? So I'm mainly mentioning this to say you might run into something like this. It may seem similar, like this rule for multiplying like things and adding the exponents, but it's not the same, okay? But adding like terms applies to anything, anytime you have the same thing that's being added or subtracted, okay? So we could say 7y to the 4th, take away 2y to the 4th. It's like apples and apples, okay? So say you had 7 apples and you took away 2 of them, how many would you have? You have 5 apples. So by analogy, that's what I'm saying is happening here. 7y to the 4th minus 2y to the 4th is 5y to the 4th, okay? All right, now our next rule refers to division. If you divide like things, you subtract the exponents, just like this, okay? If I have y to the 7th power and say I divide by y to the 4th power, dividing amounts to subtracting the exponents. Always I take the exponent on top minus the one on the bottom. So 7 minus 4, okay? Division amounts to subtracting, that's 3. So this amounts to y to the 3rd power. All right? Now that is true no matter what. Like, you know, you could say if you had x squared over x, okay? So that's a different symbol, a different variable x. It's different than y and so on. But I always take that exponent on top minus the one on bottom there. What's the one on bottom? By default, what's the exponent if we don't see one? It's a 1. Okay, so this is x squared over x to the 1st power. That's x to the power 2 on top. Take away 1 on the bottom, which is just x. Okay? All right. Now, I'll give you the rules. Doesn't mean you can't find some way of your own to do this. What's another way to think about this? X squared is x times x. And divide by x, what's it look like happens there? It looks like that you could cancel, and what are you left with? Just 1x, right? So you could be flexible in how you think about things and find your own way to do it. All right, now why might we have the rules? And I want to give you another example, but I want to give some kind of a justification for the rules. So the rule would apply anytime you divide like things, okay? Anytime the base matches, all right? So here, y and y, or x and x, and so on. Here, I got the bases 578, so I want to do this calculation, 578 to the 99th power over 578 to the 90th power. If I give you this one for this reason, it's I take my desk calculator, my handheld calculator, this one, if I tried to do that one with my calculator, say I did 578 to the 99th power, then as soon as I type that in, okay, and I press enter, it's overfloated. It's just too big of a number. Now, I think if you used a nicer, more powerful calculator than this one, or an online calculator, you might not have that problem. But I mean, you can have numbers bigger than the calculator can keep track of. And you would run into that if you directly try to do a calculation like this. But we have a way around that with this rule. The rule says anytime we divide like things, we subtract the exponent. So, given that these bases matches, okay, and I said this so informally when I made the video, on both these rules, I'm probably being too informal. It's whenever the base matches, right? Okay, like y and y. If the base part matches, that's what I mean when we're multiplying like things. Or here, y and y, again, if the base matches. Or 578 and 578. Now, say that we do have that, then what should the exponent be? I did say that the rule is that you take the exponent on top and you subtract the one on the bottom. And so what should the exponent be on this number 578? It should be 99 minus 90, which is just 9. Okay? And then if I got my calculator and I did 578 to the 9th power, it would be able to do that without overflowing the register. Okay? All right. So let's see, one more rule. If you ever had the situation where you had subsequent powers, then you would multiply them. Okay? So, in other words, like this. Now, well, hold on, let me pause for a second. You know how I said I'm describing things so informally, like when I said divide like things. It might be more proper to say that we want the base to match. If the bases match and we're dividing, we subtract the exponent. And sure, that's true, okay? But I think most people probably learn the rules by seeing some examples and then recognizing similarity in other places. So, my description for this third one is that we're going to multiply subsequently applied powers. Meaning, if I have an x, and then I raise that to the second power, and then in the next step I raise it to the 5th power, then we multiply those together. Okay, that's what I mean by subsequent powers. You know how there's an order of operations in arithmetic, and we always start with the parentheses? So if I was going to do this calculation, you know, directly, I would have to take this number x and square it and get a result there, and then after that I would apply the 5th power to that. So that's what I mean by saying these are subsequent. But, alright, if that's what it is, you can, as a shortcut, multiply the powers together and just have one exponent. So x squared then raised to the 5th power, which is how I'd read this one, is x to the 10th power. 2 times 5 is 10. And let's see one that's a little bit of everything. So here's two different rules. One of them is the one I'm just talking about that will multiply subsequent powers. What is n raised to the 4th power then raised to the 3rd power? Well, you see I have it written over there that it's n to the 12th, but yeah, just that part is n to the 12th because 4 times 3 is what we should apply there for the exponent. You multiply subsequently applied powers, and then I have that times n to the 7th. What do we say when we multiply like things? Like if we multiply things and the bases match, okay, then we add the exponent. So then with that thinking on this one, I would say, all right, those are like bases, n to a power times n to another power. I just add the powers together. That's what you do when you multiply like things like that. That's how I get n to the 19th power. Okay, now that's a crash course on exponents. There's many, many more examples to give, but hopefully I did it in a way it got you thinking a little bit. You understand at least what the basic rules are, the basic meaning, and maybe triggered your memory on some things that you had forgotten.